Hey everybody, welcome to Eureka Math / Engage New York Math, Module 5, Lesson 14, Volume in the Real World. I'm Mr. Quick, and today we're going to look at a couple of kind of real-world examples in which we can find volume, and kind of an interesting way to break apart a three-dimensional figure and find the volume for different sections of that figure, putting it back together to ultimately find the volume of the whole thing. All right, so let's take a look. A special order sandbox has been created for children to use as an archaeological digging area at the zoo. Basically, big sandbox, right? Determine the volume of the sandbox. Well, if you look here, what we end up having is a weird shape. It's kind of like a sideways L, it looks like, right? And so to find the volume, it looks intimidating because we have 1, 2, 3, 4, 5, 6, 7 different numbers in this particular shape. But what we can do two things. We could slice this way, in which case you end up with two different shapes. You have that long back piece, and you have this front piece. Find the volume of both, add them together. Or we can cut it this way. If I can do that a little bit better. Cut it this way, and we end up with this piece on the left and this piece on the right. So think about that. If that was like a sponge, right, you could cut it right where it connects right here. And then you have two different shapes. Find the volume of both shapes, put them back together, and there you go. You've got your full volume. So let's start with this shape on the left. So what we have on the left, I'll put L over here for left, and I'll also put it on the left side. We have 2 3/4 times 2, right? So we have this and we have this, times this portion here, which we don't know, that's not labeled, but it's the same size as this portion over here, so we multiply that by 1/5. So we do have to look and kind of see if something's missing here. Is there another piece that is the same size elsewhere on the shape? So 2 3/4, we have 4 times 2 is 8, plus 3 is 11. We end up with 11/4 times 2, which we can also say is 2 over 1, times 1/5. 11 times 2 is 22, times 1 is still 22. 4 times 1 is 4. 4 times 5 is 20. We end up with 22 over 20, and that's the volume of this portion here. Now, to find the rest of it, we've got to find this portion, right? We'll do this in green. So, what we're going to use here is we want to find our base, right? So we have our length times our width, and then we have our height here. So we're going to end up with 2 1/4 times 4 1/3 times 1/5. We don't end up using the 5. The 5 is split up into this portion and this portion here. So if you add this number and this number together, you would get 5. Okay. We also don't need this 2 1/3 because that's just this portion here. If you take this 2 1/3 and you take this 2 that's over here, guess what? You get the length of this whole piece, which is already here, 4 1/3. Okay. So we're going to then convert these. So 4 times 2 is 8, plus 1 is 9. So we have 9/4 times 3 times 4 is 12, plus 1 is 13. Denominator stays the same, 13/3 times 1/5. 9, well, let's say 13 times 1. We'll do that first because that's just 13. And then 13 times 9 gives us 117. We have 4 times 3 is 12, times 5 is 60. We have 117 over 60, which we can simplify, which I'll write over here, into 39/20. And then we can add that to our 22/20 that we have here, because we have to put the parts back together, right? Put the pieces back together. We end up with 61/20. 20 goes into 60 3 times. There's 1 left over to get from 60 to 61. Denominator stays the same. So we end up with 3 1/20 meters cubed. A lot of steps, go slow, but not a lot of hard math. right? So a lot of steps that you have to keep straight, so there's a lot to it, but not a lot that's super difficult. Okay, let's take a look at this question. If this is our fish tank, what is the volume that the tank can actually hold? Well, we're going to find our base here, so we have 3/4 times 1/4, and the height of the whole thing, forget the fact that it's not all the way full, we want to know how much it actually can hold. The height of the whole thing is 3/5. So we end up with 3 times 1 is 3, times 3 is 9, 4 times 4 is 16, times 5 is 80. We end up with 9/80 meters cubed. Now, different question. Let's find the volume of the water that is in the tank. So just the water that's already in there. Not how much it could hold, but how much it is holding right now. Well, base is still 3/4. Okay. Width is still 1/4. But now we're looking here that it's only 3/8 meters full. So we're going to multiply it across here. 3 times 1 is 3, times 3 is 9. 4 times 4 is 16, times 8 is 1/28. So we would, I'll put the answer over here. We'd have 9 and 1/28 meters cubed. Okay. We're going to stop there for now. We'll look at some more examples in class. Thank you for watching, and we'll talk to you soon.